Hey, folks, welcome to this mock interview by SDE Skills. This is 1st of May, 9 p.m. or 9:06 p.m. on Saturday PST time zone. We have Elliot, who would be the interviewer today, and we have Shreyas as the candidate. Coderpad is all set to go. Elliot, on to you.
Hi, Shreyas. I'm Elliot. Do you want to introduce yourself a little bit? You don't have to do too much because this is, anonymous, but feel free to do a little bit.
Yeah, currently I'm based from Bangalore, India. I'm working in VMware from last 2.5 years. Before that, I worked on EMC. And the domain I worked on the networking domain and system kernel domain. And that's about me. And yeah.
Cool. I guess I'll just jump right into the question. I'll just paste that into chat, and you can, into the top here. I see you've chosen C++, so I will comment this out for you. But you can just read it, ask me questions, whatever you feel like doing there. There we go.
This is a treasure hunt and measure series of checkpoints located each checkpoint in a box which may contain a key, and if they unlock one of the box at another checkpoint. Information that must be deleted and it is too much text. Can you give me some example and brief me?
Yeah, there's an example. There's an example at the bottom here.
Okay.
So this is basically each one of these sublists here is a map fragment. And so, for example, this fragment contains Seattle, Salt Lake City, and Denver, and it's telling you Seattle has to come before Salt Lake City, and Salt Lake City has to come before Denver. And then the output here, you can see that Seattle is before Salt Lake City, and Salt Lake City is before Denver. And essentially what you have to do is you have to take these individual fragments and come up with an output that contains all of the elements that's consistent with the ordering of each of the sublists.
Oh, okay. So is it kind of visiting from the from starting point to end of the city, something like that?
So you do need to visit all of the cities, yes.
And okay, so what is there any, you have any starting point of the city, or we can pick, we have to scan and figure it out?
Your job is to, it's possible that there's multiple valid starting points.
Yes.
You need to return a path that has each of the elements in a valid place within the order. Okay. So it's possible.
So, yeah, the input contain only 3 city, or it can contain more city?
It contain, there can be any number of sublists and any number of items in the sublists. For the moment, let's assume that sublists have at least 2 items for simplicity's sake.
Yeah, currently it is 3 items, right? It means Seattle is come first, and Lake City is come second, and Denver is come third, right? It's like that.
Yes, that is one sublist. That is accurate. Yeah, and then there's these other 2 sublists as well in the input.
Yeah. So what I'm thinking is it is kind of a topological setting. So first of all, I have to figure out all the edges of the edges, means from edges. Then I have to scan from the city where the input in degree of the city is 0. And from there I scan through all the city and put in the list.
Okay. Yeah, that sounds reasonable. Why don't you start? So what data structure are you going to use? Just to be clear.
Yeah, so I will be use from map to cover to first figure out all the neighbor city, like Seattle have the neighbor city of Lake City have neighbor city Denmark, and New York have Phoenix, and Phoenix have the Denver, and Volker have the Mine School, and Mine School have the Lake City. Like this, I have to first figure it out. And is there a possibility of, is there any possibility of there is a loop in the loop in the city?
Yes, you absolutely could have a loop. How would you deal with that?
Okay. Okay. So in this we have loop in the city. Then we need to expect you to return anything, or you have to exit as written as a failure.
So if there is a loop, then you should just return an empty list to indicate that there isn't a valid ordering.
Okay. Okay. So first of all, I have to get all the in degree of the city, and I will start with the in degree of 0, and put in the queue. Okay, and from the queue I have to keep on scanning and next forward, and put the in degree of the neighbor of the queue who are in the queue, make to 0, and keep on putting in the queue, and we keep on moving until I did not find it. I keep on moving till the queue is empty, and put on the list output.
Okay, so if you were going to start running code, what is the first thing you would do here?
So I have to first figure out all the neighbor. Okay, neighbor. I have to create a map of neighbor. Then I have to put and get the in degree of all the node city. Then I have to scan from there itself.
Okay, so let's start with the first couple of steps there of building that map.
Map. I have to create a.
No, I mean like actually start writing the code. Your plan sounds good. So let's start writing the code.
Okay, fine.
And I'm just quiet because I'm just watching what you're doing. I'll let you know if anything doesn't make sense to me.
Yeah.
So far seems good.
So what exactly I'm doing, I'm creating the graph from the inputs. Then I have to do topology setting. Here I'm constructing the graph now.
That makes sense. I do have a question. So on line 42, you say you have city in cities, right?
Yeah, actually, this is yes, some wrong assumption here. Okay, cities in.
I think that's just, you mean ordered cities like that. Yeah, ordered cities. That's what you need to do. Yep.
So I constructed the graph now. Here I have created neighbors of each city and in degree of city make it to incrementing, and likely I have performed. I have created the graph now currently. Now I'm going for the solution now.
In degrees. Let me see here. And so I was thinking these, I guess, so what if cities of I is not in the in degree map?
Yeah, it is not there, then it will be considered as a in degree 0. So that is the starting point of the graph to be traversed.
Well, no. So, I mean, maybe I haven't worked in C++ in a while, but generally, if you try to reference a key and modify it in a map when it isn't there, it's going to throw an exception, right?
No, it will be create as a 0, then it will increment to 1.
Okay, if that's the behavior, I know in somewhat there are like default fix in Python behave like that, so we can assume it's going to behave that way. That's fine.
Yeah, this will work.
All right.
So I am taking a queue now. So I'll be check all the in degree city to 0. Will put first in the queue. From that onward, keep on traversing the queue.
Yeah, I mean we went over that, so yeah, let's see it.
So this I am taking as a marker of whose city are visited. So I will not revisit it again if there is a though to take care of the cycle in the graph.
Okay. why do you need this extra all cities set?
Okay. Yeah, actually, if I want all the city, because I want to scan all the city and figure out the in degree of city should be 0. So here I am want to get all the city, and I want to get which city has in degree 0. That's why I need all the cities.
But your in degree set on line 38 should already have all the cities, right?
No, it is not all the cities. It is contain the cities whose has in degree is greater than 0.
Okay, would it? That's fine. You can do it that way. Continue.
So I constructed the queue first initial queue from the in degree 0, and now I'm checking if a queue is empty or not. So here there is no starting point of the city, so I am making return empty. So for the city there is no output going to be written here. So I am now scanning through the queue and checking the queue is empty or not. After checking and keep on doing this process till queue is empty.
Yep.
So here I missed one point. I have to mark as visited city, which I have missed here. So I'm decrementing the count of in degree of neighbor city. Then neighbor city count is 0. Then neighbor city count is equal to 0 and not visited yet. And it is not visited yet, then I'm pushing that pushing this city to the queue again. So this process keep on doing till a queue is empty. Now,
Mm-hmm. Yeah, I figured. Soul ordered city. Did you create that variable somewhere? Because I'm not seeing that. Oh, okay, that's all the way up here. And that's going to be an array. Yeah, in Python, that would be a dictionary byte because that's an array. Line 57. Yeah, this is a ternary statement. And why are you using this ternary statement here? Can you explain that?
Because the objective is to check all the city are visited. If not all the city are visited, if all city are visited, then I am returning the order of the city. Otherwise, returning that empty, because there is possibility of loop. If there is a loop, we are not visiting all the city. So that's why I'm returning empty if not all the city visited.
Okay. What function is this visited city set doing? Like, what would your code look like if that just didn't exist? Why do you need that?
I need it because if a city is already visited, I don't want to visit it again to avoid the cycle in the cycle in the cycle in the graph.
Okay. Let's work out a simple scenario with a cycle. So literally, it can just be could be as simple as A, B, A.
You are writing somewhere else?
I wrote that up on line 34, just ABA. And let's assume you've created the graph, and let's walk through that example and think about what would happen.
Okay. Is it complete?
Let's say that, let's just really simple example with the cycle. Let's say that's the entire thing. Yeah.
Okay. Okay. So here ABC, ABA is there. So here in the graph, what happened here for each city, what I'm doing in this line.
Assume you've created the graph. So let's skip the create graph part and just jump straight to the what did you call this function?
This one, line 50.
Yeah. Yep, that one.
Okay, so here after this graph is constructed, so it will be go like this. A neighbor will be B, and B neighbor will be A. Okay. So and the in degree of A will be 0, in degree 1. Okay. And in degree of B will be 1 as well. Okay. Because A is coming before coming after B, and B also coming after A. So after the line number 41 to 52 is performed, so this will be the graph. This will be the graph.
Let's jump down to line 62.
Yeah, line 62 is city. In all the cities contain only A and B. Okay. So in degree of city is equal to 0. Okay. A in degree is now currently we have 1, and B in degree is 1. Okay. It is not equal to 0. So none of the city is going to be in. Okay. 1 second. I missed this slide. Yeah. So in degree of city is 0, okay, not 0. So none of the first thing going to be insert into the city queue and visited city. So here city queue size will be 0. Okay, it will return empty.
Let's say we didn't have that line. Let's keep going. What would happen then?
If this will be there, then I don't have any starting point from where I have to start scanning to the scanning scanning to the okay, this will be empty also. Okay, okay, right. So it will be, yeah, right, yeah.
So you're saying it'll skip this, right? Because city queue is empty.
Yeah.
Okay, so what happens after that?
It will be empty now, so it will be come to here. So here it will be, if both are not equal, so it will be written empty here.
Okay. So where did your visited queue get used dealing with that cycle?
The visited city you are talking about, this one?
Yeah, you said you needed that to deal with cycles, but it seems like we just dealt with the cycle without it. So I'm confused. Maybe I'm missing something, but it doesn't seem necessary to me.
Okay, so visited city, some scenario like
Yeah, maybe you could show me an example where you think that's necessary.
yeah, okay. Yeah, actually this is also not required because I am checking the in degree of 0. So this is also not required visited city. So
Okay.
this thing also we can remove.
Great. So what is the runtime of this algorithm?
So runtime complexity will be order of n, because we are visiting each city is once only. So it is order of n.
What is n?
N is number of node in the graph.
N is, so it's solely based on the
city. It is the number of city. It means city is kind of number of all city.
Okay, so it's solely based upon the number of the cities. Is that what you're saying?
1 second, what happened? I lost.
Can you not hear me?
Oh, okay, 1 second. Okay. Yeah. So this is where n is the this is the time complexity, and yeah.
Okay.
And
Let
space
us. Go ahead. Yeah, tell me what you think space complexity is.
This is also order of n. So I'm not taking any extra space. It is which is total number of city also.
Okay, let's look at an example here. Let's say it's a good way to do this. See. And then let's say we have. Okay. Well, I don't know. Example. Sorry, I probably should have an example for this. Sorry, it's interviewer flaw. But have you heard of the distinction between sparse graphs and dense graphs?
Yeah.
Okay, so let's say we had a very dense graph with lots of connections. Would that impact the running time in some way?
No, it is not impacted because I have the put checkpoint of in degree 0. So it will not created any impact. So whenever I am taking in degree 0, I'm directly pushing to the queue, and I'm not processing further that point. So it will not create any impact.
Okay, so you have this inner loop here on line 77, yeah?
Yeah.
And that's going through neighbor cities, right?
Right.
So if there were a bunch of neighbors, then this loop would potentially take up more time, right?
Yeah.
And the
yeah.
number of neighbors could vary even if the number of nodes n was the same, right? Because you can imagine a situation where, very simple example, you have
Got your point. Yeah.
So how do you think that affects the running time?
Yeah. So in this case, to avoid this thing, what I can do instead of here in line number, it is now. Yeah. So here I'm creating vector of city neighbor, right? I can create a set. Okay. I'm taking the set. So it will be contain the set, and after the node is getting visited, I delete it immediately from here. So this will be if not it will be deleted from that
No. So
yeah.
my question wasn't about like the correctness of the algorithm. My question was about the runtime of the algorithm.
Yeah. Then it will be because you're visiting all the neighbors, even though it is visited. So it will be increase the time complexity. Yes, right. In this, yeah, right.
So what is the time and space complexity then?
So then it will be order of n square.
Why would it be n squared?
Because if we considering each node is connected to all the nodes, okay. So
Well, that's one case, right? But it doesn't have to be connected to all the nodes. It could be. Let's say you had 10 nodes, and let's say you had 10 nodes and you had 10 edges. Are you saying that the runtime then would be 100?
Yeah. So it will be 10. Okay. So you have maximum 10 edges for each node, and then time complexity will be the n into 10.
Okay. Let me see what else I want to talk about. Grab this here. I have time to talk about this. It's kind of a quick follow-up, nothing too huge. Boom. So you can read that, all right? We only got a few minutes left, so I can just summarize it. But basically what this is asking is this will output a valid total ordering of the graph. Can you think of a way to modify your algorithm to indicate whether this is a valid total ordering or the only possible valid total ordering?
There is other possibility also valid ordering is there. It is based on that how you are scanning and this is not only valid ordering. We can have also other valid ordering because this is depend upon the line number 62 to 67. So the way we are inserting in the queue. Okay, so if we change the order of inserting into the queue, the order will be changed.
Yeah, so like for example, of an input of ABC, there's only one valid output, right? ABC. Yeah. But in like many of the other examples we've given, there's multiple valid outputs. So I'm wondering if you could modify your function to like return what is currently returning and then also return a Boolean that indicates whether or not this is the only valid total ordering, whether or not there's other possibilities.
Okay, so for in that case, what in this case I'll check here in the size of the queue. Okay, here I'll put one check here. So this is the checkpoint. Here I'm checking if queue size is greater than 1. There is multiple possible of valid ordering. So this is the checkpoint I can put it here.
Okay, and then you could just return that as like I don't know if you can return multiple arguments in C++. I think you probably just need to return a list or something, but yeah.
Yeah, I put it check. If it's required, I can put the return value here to a boolean. Then I return this value instead of returning this.
Cool. We got 3 minutes left. Is there anything you'd want to change about this code before we're done? You want to maybe look it over quickly, see if you see any bugs or anything like that.
I can remove visited city. This comment I will remove. This is only commented, and yeah, nothing. I don't think anything required to be changed here.
Yeah. I mean, we can stop there. In a real interview, I'd probably have you run through like one more test example, but I don't want to run over for this, so I think that's a good place for us to stop.
Okay, the second question you have put, this one?
Yeah, you already answered that. That's what we just talked about.
Okay.
Cool. I think we are done with the interview part.
Okay.
So does the moderator ever want to step in and yeah.
Yeah, I can jump in. This is good. Hey, thank you so much for taking the time to do this. So first, actually, you know what? Let's actually go to the audience first and see if they had any specific question about the question itself. So let's take about maybe 10-ish minutes and then talk about the question, like what would be an ideal solution, whatnot. So AJ, Ashwini, Jiashen, feel free to unmute and ask any questions or provide your feedback and comments on the question itself. This is not Shreyas's performance or Elliot's performance, but just let's talk about the question itself. Do you think it made sense? Was it easy enough? What do you guys think?
Hello, hello everyone. I'm Jason. So I think basically the interview did a really good job. One thing I want to mention is about the data structure. So since I saw it is using a set data structure, so I think an ordered set would be great, since for set the time complexity for insert or anything is O of log n, not O of 1. The second recommendation is I think we can add for the for loop in order not to copy the data. Yeah, like for example, like in line 62 and line 82. Yeah, we can basically add and yeah, that's what I want to say.
Okay.
Okay. Any other question about the question itself or the solution presented?
Actually, I joined it late, so I missed the question.
Elliot, can you summarize your question like one more time, like quickly for the benefit of the audience?
Yeah, sorry. Can you hear me? My Zoom window has escaped somewhere, but am I muted?
Yeah, we can hear you. We can hear you.
Okay, great. So the question is pasted at the top. So maybe the person who's showing the video could scroll up. But basically, you're engaged in a treasure hunt. And you have a series of map fragments, which are represented by the input list. And those map fragments tell you, like, you have to visit this checkpoint and then this checkpoint and then this checkpoint, you know, a certain number. Do you have to visit a certain subset of the checkpoints in an order? And you have a series of these fragments, and your job is to merge the map fragments together to output a list of all of the checkpoints an order in which you could visit all of the checkpoints, which is consistent with each of the individual fragments. That makes sense? Do you have questions about that?
Ashwin, does the question make sense?
Yeah. So I see the example of Seattle, Salt Lake City, and Denver in like as a one element of the like it's array in array. So are you saying that these three cities are like they are visited in order, like first the Seattle, then the Salt Lake City, then the Denver, like that? Or
Yes, so you don't have to visit them one after the other, but Seattle has to come before Salt Lake City, and Salt Lake City has to come before Denver. So for example, in your output, Seattle is first and Salt Lake City is like fourth, and then Denver is dead last. So the order is maintained, but they don't have to be contiguous.
yeah, okay, thanks. Now kind of makes it clear, the question.
I mean, the question is supposed, I mean, there's even certain things in this question stem that like aren't necessary. And part of that is like literally the stuff about like geographic coordinate systems is like totally irrelevant to the question. But there's just supposed to be some stuff in there that's ambiguous so that you can ask clarifying questions and kind of weed through that. Yeah. Does anybody else have questions about the question itself?
It doesn't look like it. I think we can probably just move on to the next stage, which is so Shreyas, how do you think you did in the interview?
I did something. I did some mistake, like during I add some city queue unnecessarily, and visited city also I have add. So that's what I did mistake. And first thing is this is very huge text, so I face difficulty to understand it fast go. So then I asked for the example so that I can grab the question quickly. So that I asked. Yeah, that is the some of the mistake I done.
Got it. And which part do you think you did reasonably well? Let's talk about the good side of the story.
Yeah, I able to extract the solution of the solving part quickly from after getting the example part. And also I have taken care of if input cities contain more than 3 order, then I have also taken care of that in this part. So it is not specific to only 3 in the city list, so it can be taken all the list. So that I have taken care of, and I also taken care of the boundary cases. This boundary cases I have taken care of all that. Yeah, that's part I done better. And some of that mistake I done, like visited city I have had, I should not be consider this part. We have done mistake.
Got it. Okay. Questions from the audience, like any feedback for Shreyas? We've got like 3 folks at this point of time. I think Suman just joined pretty late, so not sure if you have any feedback, but AJ or Jeshen, any additional feedback for specifically for Shreyas or for Elliot? All right, so if not, Elliot, it's on to you. So how can you just like share your perspective on how the interview went?
Yeah, I mean, you did well. It's clear that you know the algorithm very well and were able to identify the algorithm, so that's good. But at the same time, then I'm going to expect a little bit higher level of performance as compared to somebody who is like figuring out the question as they're going along. So in terms of things that I noticed, in terms of opportunities for improvement, there's a couple of variable naming things, like L. I don't know why this. There was the L one. There was, I think, there was that thing which we fixed with the cities on like line 43, where the naming of the sublists didn't quite make sense. There's a couple things like that. I really like that you used a class and had private and public methods and had like the structuring of the code was good. there was a couple of things that just weren't necessary. For example, on line 69, the city size equals 0, and this visited city stuff. Yeah, like that wasn't necessary, and it was a little bit concerning that you stuck for quite a while to insisting that was necessary. That kind of makes me wonder, do they really understand the code, or do they just kind of memorize a solution because they got this like extra stuff in there that isn't really doing anything? Let me see, looking through my notes here. Oh yeah, the stuff with the set of all cities, I think you might have mentioned this. But yeah, it would be more, I mean, obviously it's a constant time improvement, but it's also just like less stuff in your code. If you just make sure that every city goes into the integrity list and then just use that, and you don't need this all cities one. One of the people commented that they thought that insert into a set is log n. It depends upon which type of set it is. So if you're using like a hash table to implement your set, then it's going to be constant time inserts. But if you're obviously using like a tree set, then it'll be log n. I think we were assuming that it was a, you know, some kind of hash set. I think it may
a hash set with collisions might potentially be much more, but yeah, the typical case is O of 1. I mean, you can, if there are collisions in the case, like if you so happen to be super unlucky that your hash function is actually returning the same hash value, then a hash set might actually be devolved to O of n for insert. But in any case,
yeah, I'm assuming that, you know, we have a reasonable good hash algorithm, and we're resizing the backing array and stuff like that.
yep.
But in this case, you can do unordered set, so it will be order 1 always. Unordered map, instead of map, I can do. So this. But
the big thing was the big problem was, and the biggest concern was the big O runtime. So the big O runtime of this is V plus E, where V, and that's true for both memory and for runtime. And the way to think about that is that your algorithm is, it'll touch, in the worst case, it'll touch every single node, and then it'll also touch every single edge once. And that's where I was trying to get at, where I was like, hey, you've got this inner loop here that's touching all of the edges. So you were kind of in the right direction. Like if they're the same number of edges, well, not really, because you said it would be O of n squared at the end. If there was the same number of edges as the same number of nodes, then it would be O of n plus n, or O of n. And so that's not, I mean, it's important, but it's not a huge deal, especially with an algorithm like this where it's a little bit less intuitive. But it's one of those things where it's like, hey, this person knows this algorithm really well, but they don't understand, you know, the runtime. So that's a little bit, you know, concerning. Yeah, okay. That's what I've got.
Yeah, thanks for the feedback. Yeah, thank you.
Hey, so I've been following this interview. A couple of things I liked overall was, I think the question is definitely not something that I had seen before, but like, I mean, at the end of the day, it does evolve to something pretty straightforward. So that's like the interesting part of the question. So one suggestion or like sort of recommendation probably for you, Elliot, would be to see if you can build the question in a more simpler way and then make it more complicated like afterwards. So the same thing, have like a simpler form of the question. So that way it gets the interviewer, you know, gets the candidate situated with the question. And then you can follow up with like a part 2 of the question, which actually makes it like harder. I think you have part 2, but I think you went from moderately hard to extremely hard or something like that, as opposed to easy to moderately hard or easy to somewhat harder. So that will be one feedback. But again, on the good side of the story, I did see that, I mean, there was a lot of good nudges, pushes. I think you were hand-holding at the right points of time. I think you also had like a good way of following up and figuring out, like, you know, you were on top of the performance, like Shreyas's, you know, diversions and digressions, and you're able to, like, you know, pull back wherever necessary. So I think a large part of like getting to the final stage is like credit goes to you for guiding the interview well. And I think you would have gotten, I think you shared the signals, but I think you got all the signals that you would need from an interview. If you were to look at this interview just by itself, in and of itself, in terms of its strength, would this be like a more likely than not move forward to the next stage, or would you say not move forward to the next stage? Where is your head at?
That's a complicated question because it depends upon. I mean, it depends upon what role you're interviewing for.
Let's assume it's a junior engineer, like, only coding.
Like,
that's all you're assessing for.
Like an entry level.
Yeah, very entry level.
Oh, absolutely, for an entry level role, absolutely, I'd move this forward. Yeah.
Move forward, right? Yeah, because that's because the thing that you're looking for is coding fluency, the ability to understand and solve the problem, and familiarity with Big O and understanding of all the concepts. And I think I can just say check for all the three, and that's why it's like a move forward. Communication, understanding, like, back and forth and making those things. I think there's a little bit of softness there, but I wouldn't be too worried about it. Maybe for a slightly senior candidate, I might be worried about the level of communication or the method. So it's not just the choice of words and the pronunciation. It's more to do with, like, there were like quite a lot of dead spots and, like, silent zones where you were just coding, Shreyas, and no discussions, nothing. I think Elliot did quite a lot to, like, provoke you to speak at times, which was interesting. But then it's not, you didn't naturally start, talking. Talking and coding is not a skill that people have, but it is a good skill to develop, especially for interviews, because then you can say, this is what I'm thinking, here's what I'm going, here's what I'm doing, and things like, and those things actually help you with getting this in a good place. So think about that as to how you want to build that skill. So the one of the things I do repeat from the top to bottom is that there are 4 parts that I want people to cover in their interviews. The first part is essentially understanding the problem itself, like asking for clarifications and things like that. I think that part of it was reasonably done, the way, at least that's how I see it, where there is a lot of confirmation, questions, clarification about the interview, inputs and the outputs, and the process itself. So I think that was reasonably done. Second part of it is the problem solving itself, and I think that was done very well, like, understanding the different algorithms, the data structures, and whatnot. So that also happened well in my mind. The third part of it is the coding, where you're talking about coding fluency. Are you using the right idioms? Are you checking for things like null values, empty edge cases, and things like that? I generally hate ternary conditions, but I mean, that's okay. And you also had using, like, the right methods. I mean, you wrote code that kind of compiles, I assume, right? I mean, I don't know whether you ran it or you tested it, but that's like, in most cases, you may not be able to run it because the IDEs usually have running disabled for many companies, because they're looking at the algorithm and approach, not necessarily the final code. So you did fairly well in terms of, writing legible code and consistent code. So that also was on the higher side of the story. The last one is around testing and debugging. So I look at it in 2 parts. One is to see if you were testing as you went through the process. Did you test each submodule, each method that you wrote independently, each for loop is independently evaluated before you evaluate the big thing? And that's one. And the second thing, of course, is once you're done, did you go back and run it with the inputs that were given to you and without prompting? And that's like a question I had. Maybe this is like an Elliot question. Like, how do you think Shreyas did in terms of testing his code,
Yeah,
like, as he was going?
Yeah, I usually do testing, keeping in mind in the example what is in there. So I'm keeping running the test cases in back of my mind while running in the code. Like this is if line number 45. So I missed this line, so I added later on while running through the dry run of the test cases. So I do in the back of my mind all this testing.
Yeah.
Nice.
So usually, I guess I could be more passive in, like, waiting for the candidate to test their code. I do tend to take a little bit more of an active approach and, like, give them examples and ask them to run through examples. But yeah, I mean, when I gave them, I don't actually necessarily expect them to, like, write unit tests, but usually I'll give them an example and expect them to walk through their code and explain what it was doing. And we did that with the cycles example. And so the concern that I mentioned was that they had some things like this visited city stuff in their code, that even as we were walking through the examples, they like kept clinging to like needing that. And so that's where I'm thinking like, that's where I would see a little bit of weakness vis-a-vis testing, is if they're running through examples and they're not quite fully seeing what the code is doing. But I mean, overall, you know, it's a minor thing.
Yeah, no, fair enough. I think so. That's like good feedback for you for future interviews, right? Where I think your goal here is to assess the candidate's thought process and performance and whatnot. So, do they test the code on their own, and are they able to enumerate the test cases to catch the edge cases that you have in mind? Are good pieces that you want to identify. So you want to wait and watch, and almost like let them say that, yep, I'm done. It's like, then you could ask, like, are there any corner cases that you might want to test or something like that, like without giving away the question. And then how about this one? And you give them one, and the expectation would be that they understand that, hey, I think I missed this, or maybe I should try a little bit more. And they come up with the other 2 or 3 that you were expecting. And if they did that, then you should be, maybe they were just overconfident about their code. And once you shook their foundations, they were able to go back and honestly test the code. I think the thing that you need is like there needs to be a good dose of skepticism. Even if you have written the code and you feel that everything works, you want to be very skeptical, and you want to be able to run the test cases without any prejudice, pretty much in that, right? So that's the thing. So for you, Elliot, I would expect you to think about how to provide that kind of a guidance or coaching, so that you can acquire those signals. I mean, that's the only thing. But you did a very good job overall. I mean, it didn't sound like you were hand-holding a lot, in the sense that it felt almost like you were able to sense where Shreyas was getting stuck, and then you were just jumping in to save the day. So it didn't feel like it was premature. So I think good on that, but definitely something for you to see if that's something that you want to improve on. So
yeah, and I think yeah, it was easy. It is in that sense, because I mean, he largely did the correct algorithm. You know, it gets harder when it's like they're really stuck and you're like, how much help should I give them? And they're really just going in the wrong direction. And yeah, it can get tricky, but
yeah. No, awesome stuff. I think this is good. Great interview. Thank you so much, Elliot, for taking the time to do this. And Shreyas, I know coding in front of coding in front of somebody is hard, and coding in front of like a bunch of folks, especially people who are like dissecting everything you do, is super hard. So thank you so much for being brave and stepping up for this one. Thank you, and much appreciated. For the rest of the folks, I think I know I don't know why, but we have like a lighter audience today, but that's okay. We'll wrap it up quickly, just giving folks a minute or two for any additional thoughts, or we will call it a day in a minute or two. Any questions, folks?